All right, everyone. Thank you for joining the latest Trees Around the Globe student research campaign, The State of Trees, May 2026. Today is Tuesday, the 19th of May, 2026. And this is the NASA Moon Trees Legacy webinar, Building Generations of Tree and Land Cover Observations and Stewardship from Apollo to Artemis. And as you know, we've talked a lot about the moon trees over the last several years of the campaign. We really kind of ramped up with Artemis I in November of 2022. So we talked a little bit about that. You know, we had a moon trees quest for the Globe program and Globe Observer, you know, not too long after we brought when the Artemis I moon tree seeds were distributed around to those that were successful in applying for those and receiving those, and most of those have been sent out and planted around primarily the United States. I believe some went some other places, but primarily around the United States. And I will show a slide with the locations for that. But what I'm going to do now is I'm going to go over this agenda for today. Right now we're in that first bullet here, and then Peter Falcon is going to talk to you a little bit about from Apollo to Artemis. And then I'm going to do a brief report out on the results of the 2026 1-week Earth Day week intensive observation period for tree height and land cover observations. And then we will have our featured presentation, and that is called From Moon Trees to Earth Systems, Students Explore with NASA Globe. And that is a Franklin Middle School in Kenmore Town of Tonawanda School District in Buffalo, New York. And the students I have listed, I'm not sure if all the students will be here to present, but these are the ones that I had from the teacher who's with us, Lisa Valle, a grade 7 science teacher. Students Addison, Jameson, Theo, Madison, and Sincere. And we will have a presentation from them very shortly. So we're excited about that. I got a little sneak preview of the presentation, and it looks amazing. So, I won't go any further with that because I don't want to steal their thunder. And then I have a brief description with a discussion and some slides on the NASA Moon Trees effort and the Apollo Artemis legacy and how this ties into the Artemis II mission and globe trees. And then our own Peder Nelson, professor at Oregon State University. And as you know, he's been with us since the beginning with the campaign. He is a member of our team for the Trees Around the Globe Student Research Campaign. And he'll be talking about NASA moon trees as heritage trees and, 30 plus years, as you know, well, with Apollo, it's longer than that, of course, but 30, that's why I added the plus on the back of it, years of tree observations. And then we can have some final discussion and then we'll adjourn. So that's that so far. But before I do anything, I want to announce tomorrow we have a new Globe Observer Connect event, and this is going to be all about the Observe Like Artemis that is going on right now. If you're part of, most of you, almost all of you probably are all part of Globe in some way, right? That they've been having, for a while now, this Observe Like Artemis challenge about collecting observations for the Globe program. And this here is going to be where we're going to be talking to the Artemis II lunar science team members, Amber Turner and Megan Burrell, to hear how they helped prepare the astronauts for their historic lunar flyby. And they're going to talk about the importance of observations such as the ones that are being submitted during the Observe Like Artemis challenge. And here's the link here, and I can put that in the chat a little later when we have the featured presentation today. But it's observer.globe.gov/go-connect. And then you will see this, and there'll be a registration link on that page. But I wanted to show you this because this is tomorrow. Often the Globe Observer Connects are on Thursdays, but this one happens to be tomorrow, the 20th of May at 12 p.m. Eastern Time, 1600 UTC. So please check that out. Please join us for that. It's going to be a really cool event, and we get to talk to some folks who, you get to talk to folks who work on the Artemis II mission. So come check that out, please. But I wanted to get that up there because it's happening very soon. So it's happening less than 24 hours from now. So you got to come check it out. So wanted to put that up there. All right, since we're talking about Apollo, Artemis, moon trees, all that cool stuff, I wanted to share a couple quotes from some astronauts. First one is Apollo 14 from astronaut Edgar Mitchell. is a NASA astronaut on Apollo 14, United States Navy officer, an aviator, test pilot, and an aeronautical engineer. As you know, I like to have these quotes here at our webinars for some inspiration for the webinar and everything else. Suddenly, from behind the rim of the moon, in long, slow motion moments of immense majesty, there emerges a sparkling blue and white jewel rising gradually like a small pearl in a thick sea of black mystery. Okay, that is just a poetic quote. And then if we go, we travel all the way through time.
I know there's a simple thing to press, but I probably messed it up because I pressed it more than I need.
All right. Okay, Artemis II, quote from Christina Koch. As you almost all of you probably know this name.
I don't think I have.
Can someone mute whoever's talking? Could you mute, please?
I muted him, Brian. We're good.
Thank you. All right, Christina Koch from Artemis II, NASA astronaut, American engineer. She was on the ISS, astronaut on the International Space Station, number 59, 60, 61, and Artemis II missions. Her quote is, "When we saw tiny Earth, what struck me wasn't just Earth, it was all the blackness around it. Earth was just this lifeboat hanging in the universe." So just amazing. I just think these are two just amazing quotes that really fall into what we're going to talk about today, what we have from the observations that we have from the ground and from space, what we have with the presentation from Lisa and her students today, and what Peder Falcon and Peder Nelson are going to talk about today. I think these fit in perfectly for what we're going to do. With that said, what I'm going to do now is I'm going to pass it over to Peder Falcon, and he's going to talk a little bit about what we're going to do. I had to throw this in here because Peder Falcon and I go a long way back, and this was a really cool photo that we took. I believe it was, this was at AGU 2013, and this is what I call Alien Knockout. Peder was getting some type of revenge on me back in the day. I was dressed as an alien. He was dressed as the astronaut. So, a little lighthearted humor here to start off this webinar. Before I pass it over to Peder, Peder, go ahead and take it away. He's going to talk to you a little bit about Apollo, starting with Apollo 8 all the way through Artemis, and some of the really cool Earth images, that we've gotten, from these missions. Go ahead, Peder.
Thanks, Brian. I guess you can kind of entitle that also like First Contact.
First Contact.
Just let you know, Lisa has joined.
Great, thank you.
She's fine. She's there with her students. They're ready to go. Their cameras on. You can see them getting ready to rock and roll there. As Brian mentioned, keeping with the theme, we wanted to talk a little bit about the past and how we got to where we're at now. So here is Apollo 8. You can see the mission type. It's a lunar landing. It's a preparation. You can see the crew, which is Frank Borman, James Lovell, and Will Anders. The launch date as well, December 21st, 1968, and the splashdown, which was a few days later on the 27th, along with each mission has their own tagline, their own little quotes, and this is around the moon and back. You can also see the logo there of the mission. And if you go to the next slide, Brian, this is a very iconic image. This image was one of the ones that really captivated the world. It's called Earthrise, and it started this environmental movement that led to Earth Day and a lot of other great things that really took aspiration of what it is and what it means to live on Earth and how we have to really take care of it. So this led to a lot of great things in regards to stewardship for our planet. It's a very iconic image. And then many years later, many decades later, if you go to the next slide, Brian, now we have Artemis II. So if you know history, Apollo and Artemis are twins. Apollo is the male, Artemis is the female. She's a goddess of the hunt, wisdom, I believe, and many other things. And the reason NASA named this mission Artemis is because it's going to be the first time we're going to have a female astronaut on the moon. So once again, you can see here the mission type, which is a crew lunar flyby. It's like a test flight. The crew, which is international. It's not just NASA, but there's also Canadian Space Agency mission specialist there in Jeremy Hansen. You can also see the launch date and the splashdown. And for this, our tagline was "For All Humanity." You can see the logo there as well. And if you go to the next slide, Brian, here is some more amazing photography from our astronauts. This one is entitled Peeking at Earth. You can see the limb of the moon there. You can see Earth. And if we go to the next slide, now we can really get a really great perspective of the moon, Earth, an eclipse as well. So we're hoping to generate and continue to inspire that stewardship by these very beautiful photography images, but as well as, once again, continuing that legacy of what Apollo did for us and hoping that we can continue that with Artemis. And then also, as mentioned, putting that first woman astronaut on the moon and using that and seeing where that takes us in the future. And with that, I will turn it back over to you, Brian.
All right, thank you, Peter. Yeah, and one thing you mentioned there, we hope and continue to inspire, and that's one of the things that with the the legacy of what we're talking about today, with specifically with the moon trees, from Apollo 14 all the way through Artemis I. And I should it's disclaimer, we didn't have any of those seeds on Artemis II. They were on Artemis I, which is November 2022. Okay, which is that unmanned test flight, around the moon and back. So the seeds were on there. Okay, so but that whole legacy of the moon trees and NASA Moon Trees program is to inspire generations of folks in space travel and bringing things back to Earth and all of that. So just inspiration is a huge part of that legacy, and we'll talk a little bit more about that later on today. All right, quickly going to go through some of the metrics like I do each time. This is where, we have the most active countries in the campaign. You see the green highlighted countries here. The most active countries, there's 70 countries that are the most active as part of our campaign, and I thank all of you for that. These are where we get the most observations coming in for the campaign, as well as folks who, regularly attend the webinars, and we get campaign-related IVSS/VSS projects each spring, through the GLOBE program, related to the campaign with tree height and land cover and greenings, green up, green down. And here we have, this is the campaign metrics for tree height, land cover, and green up, green down observations. From year 1 all the way through year 8, and I draw your attention to the bottom, which is year 8, which is began October 1 of 2025 through today, and these numbers are good as of about an hour and a half ago when I did the metrics via the GLOBE ADAT and GLOBE API systems on the GLOBE website. That's how I pull most of them via GLOBE API. I do a little testing on ADAT as well, advanced data. Just some, you can see we're almost at 11,000 tree height measurements from 3,300 global sites for tree height, over 5,000 land cover measurements from over 2,400 global sites, and 5,870 greenings, green up, green down measurements from over 300 global sites. And for this year 8 so far, we're almost at 22,000 measurements from over 6,100 global sites. So the numbers keep jumping up, so that is wonderful stuff. For the campaign, if you look to the trees on the right, this is I put 93 webinars because this is the monthly webinars, and it doesn't match up to the amount of months that the campaign has been going, because as you remember, those of you who have been with us for a long time, there are some months that we've had multiple webinars, but we call them regular webinars because we duplicated some. Others we had, webinars in 2 parts because they were very long. We had a lot of stuff to cover. And then we've had 40 special campaign webinars, ones that we've given to, different GLOBE regions or different groups that were campaign-specific webinars. So, we've had a total of 133 campaign webinars thus far. And we have 82 blogs that are part of the campaign with, as of an hour and a half ago, again, 390,122 views. So, that number jumps up all the time as well. And at the bottom, the full number of observations that we have, for the life of the campaign so far is at 271,552. from 81,734 global sites. And as a reminder, this is a combination of tree height, land cover, and green up, green down, also known as greening measurements. So pretty amazing stuff. So thank you all for those who submit that data, all the time. I did some photo review this morning, and there was a lot in the Globe database that I had to go through. There were this morning, I think there were over 6,000 photos that I went through first thing this morning. So there were a lot. I usually do that on Monday, but I was at the NASA Goddard Space Flight Center yesterday fixing some lasers in the models with Valerie Casasanto, who is on today. So she and I were busy fixing laser modules in the two ISAT 2 models in two of the buildings at Goddard yesterday. So in the really hot weather. So I know it's hot today as well. So, all right. So last thing before we go into our featured presentation today, want to give you a quick recap on this here. This was the original shareable for the Trees Around the Globe Student Research Campaign 2026 Earth Day Week Tree Height and Land Cover Intensive Observation Period, which ran from the 19th of April to the 25th of April. Okay, because that was, April 22nd was Earth Day. So we kind of wanted to do one just for that week to see what we could do. And in this image here, the shareable, I just have some examples of tree height and land cover from the Northern Hemisphere and the Southern Hemisphere that I got from the Globe database. Okay, so here's just some examples of that. And, here are our numbers from each day. I broke it down by day, and it runs down the left side and then runs down the right side. And the middle is, and the bottom is the last day. And then the big map in the middle is showing you where all the observations came from during this IOP. So I'm not going to, you can take a look at each one of the individual ones, but I'm going to focus you on the one in the middle. So we had, for total tree height and land cover observations, we had 382 observations from 140 global sites. And for land cover, we had 119 observations from 114 global sites. So we have pretty good numbers for that. And you can see they were pretty well distributed. I did notice we did not have any from Australia, which is kind of a bummer, but that's okay. During that week, we do have a lot of observations from Australia, but we just didn't have any during that week. But you can see the United States, including Alaska and Hawaii, had some. South America, of course, Africa and Europe as well, and Asia as well. So we had lots of, coming from, all the globe regions. So, thank you all for participating in this as well. And then if you go to the IOP page, I have to put that link on here. If you go to the IOP page, this is a cool digital badge that you can grab off of there and just grab that and just, keep that, for yourself if you want. But that is one, that image that you see there is actually a photo that someone collected during one of the land cover observations. So that's a really pretty spring photo that someone took of flowers during a land cover observation using the Globe Observer basically during that week. So I wanted to include that. So I thought that was a really pretty, spring photo representative of a really cool land cover photo of springtime. So there you go. That was a look back into that intensive observation period that lasted just 1 week. So we had some good numbers for that. So once again, thank you all for the observations. Our next campaign webinar will be on Tuesday, the 9th of June, at the same time we are now, at 1 p.m. EDT, Eastern Daylight Time, or 1700 UTC and 1900 Central European Summertime. And this will be the State of Trees, June 2026. Now, this is a mouthful. Best practices and research work from the STEM Enhancement in Earth Sciences, or SEAS, summer intern program supported by NASA. An intimate look into a special issue of the Journal of Earth Observation and Geospatial Applications. And before we go any further, I'm going to ask Peder Nelson if he'd like to mention anything about this, because this is Peter's baby. This is what he does. So I'm going to ask Peder if he wants to say anything about this to preface what we're going to do next month.
Yeah, thanks for that, Brian. And in this case, the tree or the baby has grown up. But what I want to really highlight here is this was a peer-reviewed issue where you might learn something a little bit about how to present work like we're going to hear in a little bit. I wanted to highlight that this summer internship program is about 8 weeks long. And it's really important that even with a short program like that, that we share our evidence or what we find. And so this is a particular issue that we were able to work through and have 8 different participants who went through this program actually write up what they did and make their science researchable because they actually highlighted who they were, what they did, how to get their data, and many of the things that we've highlighted here. So I want to encourage everybody to come back and interview or learn a little bit from these authors. I'm sure Brian will be able to put the link into the chat. It's freely available. And again, I think it really demonstrates the way that we want to encourage our science. We've heard from a lot of our scientists that sometimes it can take 2 to 3 years, if you can believe it, to go through the peer review process. And so just recognize that it's not something that happens overnight. And we want to help people understand that process and how they can go through it. So come join us for these early career scientists. And I'll show you a little bit more later of what they actually did too.
All right, thank you, Peter. Yeah, what I'll do is after I stop sharing my screen and then the presentation gets shared, on our webinar page, I should say, where we have this listed, I have a link to the journal, but I will put that in the chat as well. I'll put a link to the webinar page and a chat to the journal and a link to the journal as well, because we recommend, you'll see on the description of the webinar, we recommend that you take a look at this journal in preparation for this webinar, because a lot of this will be covered, during this webinar, of course. So there's lots of information in there, lots of amazing articles from the C students. Peter, is a co-author on those. So, please check that out, because there are some really amazing articles from some amazing work from amazing students. So I've used the term amazing a lot, but that's definitely an understatement. So lots of amazing stuff going on. I gotta stop saying amazing. Okay. So, but yeah, good stuff. Now, with that said, we are going to now move on to our featured presentation. From the moon trees to Earth systems, students explore with NASA Globe. It's the Franklin Middle School, Kenmore Town of Tonawanda School District, Buffalo, New York. And this is Globe, US, United States of America. And as I said, I'm not sure exactly which students, I'm sorry, are presenting, but we will find out. But I have here listed as part of the program and research, Addison, Jameson, Theo, Madison, Sincere, and the educator is Lisa Valle, who is they're all on with us today, as Peter Falcon mentioned. I can't see them yet, so I apologize, because I have my whole screen filled with the presentation, so I can see everything, because I have my readers on, so I have to see everything really big. But what I'm going to do now is I'm going to stop sharing. That's okay, Lisa. And I'm going to have you share, and then I'll let you take it away.
Can you hear us?
Yes, sounds great.
Perfect. I'm going to do most of the presenting because my folks are a little shy today.
All good.
Now, are you going to post the presentation up on the screen?
I can.
Yeah, because I don't know how to do that.
Okay. Yep. Let me do that. The same one you sent me the other day. That one there.
Yes.
Got it. All right. Let me do that right now.
Will you move the slides for me, or can I do that from the?
I can do that. Just tell me like next or something. That's fine. Yep. All right. Stay tuned. I'm gonna do that. Right
Sorry,
now.
I'm new at this kind of stuff.
Oh, no worries. It's all good. All right, you should see it now. You see it?
Yes.
Is it good? All right.
All right. So like Brian said, my name is Lisa Valle, and I'm a middle school science teacher in Western New York. Franklin was lucky enough to receive one of the first Artemis I moon trees. We have an American sycamore. It's right here on our property. And I try to utilize it during different seasons of the school year, every year. And the reason why is my students don't just learn about NASA, they become part of it. And I feel like it puts them into a larger community out than just our school. It's kind of how I feel. All right, you can next. This is our little ceremony that we had at school a couple of years ago. We had news at the school. It was, you know, a couple of the kids helped me plant it. Next. Like I said, there was some news release. There's a little QR code and a link there if you are interested in seeing what has happened there. But Franklin Middle School, at my school here, and you can see that that's us planting it right next to, it's in between the elementary and the middle school, so both elementary and middle school students can take part in that. And of course, my little special thanks there to Lowe's and the U.S. Forestry. Next. And that's just a plaque that's in front of the moon tree. Next. This is just some then and now. So this was when I received the moon tree back in May of 2024. And now you can move to the next screen. And here it is over the past couple of years. And now this was us a couple of weeks ago when we went out to do some of the green up protocols back in May, well, earlier this month. All right, move on. This is some of the work that I do with my students. So in the fall, I take the kids out to do just a preliminary engagement with the moon tree. We identify it, the species, the genus and species of the tree. We make a preliminary observation. This is when the leaves are fully intact. They're usually still green. And then we also go around the park and identify 10 more trees in the park, and we make some other observations. And if you move to the next slide, you can see some of my students' work that they do. So they draw the tree, they draw the leaves of the tree, and then they have an identification chart where they can identify the particular species of the tree. Next. Then we do go out and we look for those same trees. We try to find the same trees. Sometimes we can't, but this is in the springtime when the trees do not have leaves on them yet. So we go back to the moon tree, and then we also go to different species around the park as well and try to identify trees just based on their bud structure. Next. So why I think this is important, it's like they predict, investigate, identify, track, and map species of trees all throughout our school community and along the park. And I do, when we do the green up this stuff, I don't really put into any of the protocols for NASA, but it's a good way to get them out there and observing, which the kids usually enjoy doing that. I also print a map of the park and the school grounds, and they actually locate the tree on the map, and then they put that on their data sheet and then identify the genus and species of that tree. Next. And now this is the green up protocol. I did kind of just make it my own, obviously. And again, there is a QR code or a link there to that actual worksheet that I do. So the students and I go out, we measure the leaves of the tree. Last year, I had the kids actually go into the enclosure and measure the leaves. But I noticed in July, they had damaged a lot of the veining of the leaves from having the rulers up against and kind of like squishing the leaves on the rulers. So this year I've been doing the preliminary measurements, and they will get in there probably soon and do their own because I have 4 leaves tagged. And last year I let them just pick any leaves. So I felt like I was just afraid it was going to damage the tree by doing it year after year. So this year I was trying to just give the tree a break, and the tree's doing great. It has grown. I'm actually thinking I'm going to be pruning it at the end of this year a little bit, because there is some little saplings that are coming out the side that I don't think are good for the growth of the tree. We also have a local arborist company. They come in and they supervise the person who runs Davy Tree Service. They come and they observe the tree and help me. I take pictures of it and I get their advice from things, because he told me to leave it. Because I had asked him if I should trim it, and he said no, leave it for now, because the tree needs all of the leaves it can possibly get. All right, next. So this is student data, obviously from last year, because the tree is not fully developed all of its leaves yet, full. And we collected data from May until the end of the school year, which we go right up until the last week of June. And we were able to collect a lot of good data, and they ended up being able to graph all 4 leaves that they tracked throughout that season. And the kids really enjoyed, like even these guys, they come in on a nice day, they're like, we going outside today to look at the moon tree? I mean, they always looking to go outside and do like real science work. So it's exciting as a teacher to have students come in and be excited about doing hands-on things, and especially for other companies besides just for a grade in the grade book. Next. These are just like kind of like just a little slideshow of all of the things that I do. I do measure the height of the moon tree periodically. We do cloud cover and surface temperature readings for NASA as well. These guys have participated in that several times. We didn't really get out a lot this winter. It was really cold and a lot of storms and snowy, but we do go out in the fall, late into the fall, and we will go back out soon to do more in the spring. We've been kind of focusing on the moon tree recently, so we haven't gone out to do any surface temperature readings, but we do. These guys are familiar with the surface temperature readings and the cloud cover readings and our green up protocol. And obviously they weren't here for the eclipse. And the eclipse was tricky for me because it was during our spring break. So the kids and I, we got the glasses, we tried them out. You can see that picture is in my room. Not that the eclipse was happening during school, but they were able to try out their glasses in class and look at the sun through them so that they could see how it was going to look when they viewed the eclipse observations. And I did have a few students give me data that I did put into the Globe website for the eclipse temperature readings. And that was really interesting to see how that temperature really dropped when it was a total eclipse. And some of the kids were really amazed by that as well. Next. And, that's some of the eclipse data that I captured from the Globe site based on the temperature drop during that eclipse. And then these are some other pictures of some of my students collecting data, doing the ground surface temperature readings and the cloud cover readings. And, the very first unit that I teach my students is we learn about the different spheres of Earth. And Globe has a really nice way of including all of those spheres, and then my students can participate in. And it really, to me, it works out perfectly with my curriculum. In the fall, we do weather, and we spend about 2.5 months doing weather and climate. So that's when we spend a lot of time outside doing those readings. And then in the spring, we learn about photosynthesis and plants and how carbon dioxide, oxygen, and glucose runs through the ecosystem. So it's really nice to involve the moon tree when we're talking about where plants get their energy to grow their first leaves. So next. And again, that's why that matters, is because our students contribute to a global database, and they understand Earth as an interconnected system. And of course, it's always awesome to study living things, like have an Artemis tree here on our campus. We couldn't be happier and more proud to have one. And I feel like my students really do. They love when we get the email back from Globe saying that our surface temperature readings and our cloud cover readings match those Globe satellites and the GOES satellites. They're like, was that really from NASA? And I have to like scroll all the way down. I'm like, no, look, it's from them. And they're like, they really are in awe when they know that they are participating in an NASA. I think I was faster than what you wanted.
All good.
All right. Do you have any questions?
Hi, this is Peter. Yes, definitely have questions. And for those who are online, if you want to put anything in the chat box, please go ahead and put your questions there. But yes, I do have questions. My first question is, how long have you guys been doing this for? And how many students do you have in your is it a class or is it a club?
For most of my work, it is class-based. So this year I teach about 103 kids. So there's usually about 100, somewhere between 85 and 110 kids per year. And I've been involved with Globe. I took a break from teaching. I have a daughter who's multiply handicapped, so I had to take a break. And I just started back in it. This will be my 5th year. And I've been, my first year back is when I got trained to do those Globe surface temperature readings. So I've been participating in it for 5 years. Yeah. And obviously the tree's only been here for 2, so.
We love how you have a very well protected tree with that fence.
Yeah. And I know when people see that, they're like, wow, you really, well, my husband is a contractor and he does a lot of work with Lowe's, and Lowe's donated all of that stuff for us.
That's
yeah.
awesome.
Yeah, it was really nice. It was really a big community that came together. So
I have questions for some of the students. Oh wait, there's a question in the chat box. Let me read it to you very quickly. How many hours did you dedicate per week for your investigation?
The Green Up protocol, it's obviously weather-based, and we try to go out 1 to 2 days a week to get those readings. And so, let me shut the door. I know we still are in a working parts of a building. See, someone's out there. So I would say probably about just 30 minutes a week. I would say even with our surface temperature readings and our cloud cover readings, probably just about maybe a half class period a week, twice a week. And then there's stretches during the winter that we don't really, that not too much happens. Mm-hmm. And that graphing at the end takes a whole class period, obviously, to graph those four leaves.
Gotcha. And question for the students. I know you guys are a little shy, but don't worry, we're very informal here. We have lots of students on before, so don't worry, we're not gonna eat your lunch if you say something wrong. But just curious, for the students, what inspired you to be a part of this project, and what was your favorite part of doing this type of investigation and this research?
I just thought it was really cool to go outside and look at the tree and learn about it.
Oh, we definitely have trees here. That's great.
Oh, and someone asked, how long will I have the tree? It's an American sycamore. I think they last almost 100 years. I know there's one in downtown Buffalo that they actually have it's part of a historical thing, because I want to say it's 150 years old. And actually they had to move the sidewalk and part of the road and stuff for the roots and that. So I assume it's going to be there a long time. But you guys, does anybody else have anything to add? Oh, go ahead, Theo.
They can't see me.
It's all right. Theo's over here.
Yeah, it's just very interesting that many trees. Yeah, it's just very interesting that
oh no.
Sorry.
Yeah. Oh my gosh, these guys were so embarrassed. They were oh, why we signed up?
We get it. We get it.
Another question in the chat is, how tall is a tree?
Right now the tree's about 6 feet. When it came, it was under 5, so it has grown a bit.
And one other question in the chat, or more of a comment, it's basically saying it's great how you managed to integrate the Globe activities into your curriculum. You prove that it's possible and rewarding. So well done. And that's coming from Marcus.
I have a quick question, Peter. So I know you talked about you have the fences and things around it. So since you're in Buffalo, do you do anything to prepare it for the Buffalo winters? Is there anything you need to do specifically for it, or is it resilient enough as a sycamore to withstand those winters?
Based on, because I told you we do a contract with Davy Tree Service, and Davy Tree Service just told me, like, I secured it with some like bungee kind of rubber tie downs, because he said that it's still, for its roots to really grow strong, it needs to be pushed around by the wind. So we had some like bungee cord kind of things just to make sure it didn't blow over, and those things are still there on it. We also had some barrier around so that smaller animals wouldn't eat the bark around the bottom of the tree. And most of that stuff is gone now because the tree is now 2 years old and it is pretty hardy for a smaller tree. So it's doing good.
One other question, and I want to direct this questions to the young ladies on your right, to my left. Did you notice any wildlife coming to the new tree that you guys planted?
When we went out there, did you guys see other wildlife out in the park, wandering around the tree?
I saw some squirrels throughout like the park because there's a lot of trees out there. It's kind of like the forest area, and I saw like squirrels, some bugs, and birds. Yeah.
I got you. Great. And now that I got you talking, I have another question for you. What was your guys' favorite part of your research, and what do you plan on doing next?
I thought it was really cool that we were able to be a part of like the NASA program and that we actually get to measure with the tree that was actually on Artemis. So that's what I enjoy about it. So.
Yeah, that is pretty special. Not many schools can say they have that distinction. So you're very, very fortunate, very special.
Remember when we watched the Artemis II, like we watched the launch, because the launch happened during our spring break as well. So we watched it when we returned, and a lot of the kids raised their hand, and I'm like, what? Was the moon tree on that same spacecraft? And I'm like, yes, it was. Like, and even though I told them that, they just like, it really, I think, made a connection when I showed them that launch, that tree was in that same exact capsule that those 4 astronauts were in. And I think that that's when it truly resonated how like special the tree is in our community.
Yeah, definitely. Well, if there's any more questions, please put them in the chat, and I want to encourage you guys to read through them. It looks like Allison did right. Thank you for sharing. This is a very cool project and taking such good care of your moon tree. So we'd love to see that grow and hear from you guys in the future as well. And once again, once again, congratulations, great project. And I just want you to continue to work on your projects, but also to just read through the chat box and see what people are saying about the great work that you guys are doing.
And we love doing globe. Like when we go out, I always put it on my app. I'll be walking around getting all the measurements from the kids and putting it right on the app when we're out there. And the kids, I wish that, we have a no phone policy in New York State, so the kids can't have the apps and do the research themselves and put it on right directly on their phones. So I do it for them. They like to do that.
Well, thank you once again for inspiring your students. You're doing a great job. And we love to continue hearing from you guys as well.
Thank you.
All right, Brian, I'll turn it back over to you.
All right. Thank you, Peter. And thank you, Lisa and the students. Yeah, one thing I also mentioned, I like that you did mention that, when I believe it was the greenings where, you had the protocol and the data sheet and you modified it a little bit for what you wanted to do with it, which I thought was great. You had all the information that was needed on there, but you saw that there were things on there that you wanted to do specifically. So, you modified it to the point where, it would match exactly what you wanted to do in your location. So I thought that was, really well done. And thank you for showing the eclipse things as well, because, that's near and dear to us, here at NASA, where I'm based, and, our folks here with Globe and everything. So, yeah, that was, it's a great, thing to share, because that's a big opportunity for the students to see how just the eclipse ties into the science we're doing as well, and how the observations on the ground can change dramatically during an eclipse event, and you really see that temperature just changes pretty dramatically during an eclipse event, for sure.
It was like, yeah, it was something, yeah, especially like all the solar lights went on, and it was a very surreal event to be part of. This would be the only time that some of us would ever be able to experience that, was that one and only time in our life. So it was great.
Yeah,
And,
Michael. Yeah, go ahead.
Also the tree bud identification that we did, I think I got that worksheet from Globe that I modified as well. Because I think you have something on the website as well. Like, I go through and I look at all of your activities and I try to bring them into my classroom,
That's great. Yeah, that's awesome.
Yeah, there's a lot of great resources on your webpage.
Yeah, great. Yeah, I was going to say with the eclipse, back in the August 2017, the total eclipse, I was doing some research with some folks here at NASA Wallops in the furthest part of Western North Carolina, and we thought it was interesting when it got as dark as it possibly could at that time. It was actually tricking the animals into thinking it was nighttime. So all like the nocturnal animals kind of came out, and you heard all the ones, you heard the crickets, and you heard the nighttime birds all of a sudden like come out thinking, wait, it's nighttime already? And you heard the sounds, and then when it got bright again, they stopped, which was just an interesting phenomenon that I've never experienced before. It was pretty surreal. But yeah, you really see how it changes things, and that's why we need those observations. So thank you again for sharing that, and thank you for the slides, the great presentation, and the students. Thank you for all your observations, and sticking with this, and doing some great observations, and sticking to it, and great data collection. So thank you.
And Brian, quick comment. I would say I think it would be quite interesting to see students with the moon tree in Buffalo and comparing it to students in California with their moon tree, to see how things are growing, how things are changing.
Oh, yeah.
I'm sure in California they will be quite amazed to hear that water freezes in Buffalo, being so warm here. So things like that would be a huge culture change for students in California, but that moon tree connection may be something that would be interesting for both schools.
Yeah. And since, on this webinar right now, we have an international audience. I mean, there's, just so the students and Lisa there, we have folks on right now from, Switzerland and Argentina and Croatia. So from all over the world right now that are on this webinar listening to you and stuff. And, those of you who aren't familiar, they're the students, and the school is in Buffalo, and, they, average, 2 to potentially 4 meters of snow every winter. So that's a lot. They're right on Lake Erie, which have that lake effect snow, one of our 5 Great Lakes here in the United States. So, we have there's lots of snow and wind and lots of stuff, coming. We had a Globe annual meeting there in Fredonia, not too far from Buffalo. And, it was nice, great during the summer, but we did not have the meeting in winter, so it would have been a totally different experience for sure. But, my dad grew up not too far from Buffalo. So, he tells me of the stories when he was a youngster. So, yeah. All right. Thank you. Thank you again. All right, let me go ahead and jump back into my PowerPoint here. All right, so I'm just going to give you a brief, a couple slides here to refresh you before I turn it over to Peder Nelson to talk a little bit more about, some more about trees, like heritage trees, and observations over 30 plus years. But as I said, we originally started with the Moon Trees program with Apollo 14, all the way through Artemis I. I'm going to skip by that one because we showed that one time, but I want to show you this here. Apollo 14 is when astronaut Stuart Roosa, took a pack of I think it was about 2,000 moon tree seeds along with him in his pack on Apollo 14. And then they were brought back down to Earth. And this was, sorry, I should also say, this is, you should see here, this is 1971. So this is brought down, and these were then germinated by the, you can see here, the U.S. Department of Agriculture. So he was also what's called a smoke jumper, which is interesting. So he was basically flown by aircraft above forest fires, and he jumped into forest fires from the airplane, to try to put out these forest fires, but basically jumped right into the middle of forest fires. So, very brave individual, a smoke jumper and an astronaut for sure. So I digressed a bit there, but these tree seeds were brought back and then they were germinated like the Artemis ones were in 2022 and 2023. These were germinated and then distributed around the United States. And then a lot of these were planted during the United States bicentennial in 1976 at basically commemoration events for this. And there's just an example here of one of the moon trees that you can see here. This is a moon tree, Apollo 14 moon tree sign from one of the trees. And then if we look at where they were originally, some of these don't exist anymore because some have, some have died, of course, over time. Others have been, some have been transplanted. Others are now on private property where they're not accessible. Some have been basically destroyed, torn up through like, buildings and, development, things like that. So, but this was one of the original. This was this map was created by an author who was putting things together to show where the moon trees went, because we didn't have a great record in the beginning in the 70s, actually almost no record at all of where all these moon trees went. Then a scientist at NASA Goddard Space Flight Center started to try to collate as best he could like where these trees went, and this was kind of the map that they came up with about where all these Apollo 14 moon trees end up going. So here you can see this is kind of where we went from there, basically in a nod to the legacy of Apollo 14. With Artemis, we wanted to continue this legacy, so we thought, NASA thought, well, let's put basically the same species of seeds on Artemis I, this unmanned, aircraft, as it went around the moon and came back, and then let's germinate these seeds. But, let's put out this call for applications to, schools, science centers, NASA centers primarily around the United States, applications to receive these Artemis I moon trees. So basically the U.S. Forest Service and the USDA went and germinated these seeds, and then, the process of applications were received, and then they were all reviewed, and then, they were distributed. So I should mention that the species here for Artemis I for the tree seeds were the Douglas fir tree, pine tree, loblolly pine, sweet gum, sycamore, and giant sequoia. Now I should mention that on Apollo 14, we, instead of giant sequoia, the tree seed was its cousin, the coast redwood, but NASA decided that they were going to use the giant sequoia and not the coast redwood for Artemis I, because the coast redwood still has a very limited geographic distribution as opposed to the giant sequoia, which is its cousin, which has a bit larger geographical distribution than the coast redwood. So they wanted the same family, but they didn't include the coast redwood, but they wanted to do the giant sequoia. So that's what they had with Artemis I. So this is where primarily this is the first ones that where they were distributed, and you can see they're color coded here for Artemis I. And if we zoom in here, we'd see that you'd see more and more spread out through. But this is the map of the United States where they were primarily sent through that application process. And this is everywhere from the sweet gum, the loblolly pine, the sequoia, the Douglas fir coastal, and some Douglas fir south. And then we have several here at the NASA Wallace Flight Facility where I am right now, where I'm based. So we have what's called a second generation American sycamore tree from Apollo 14. What that means is we have the first generation American sycamore, and it's at the NASA Goddard Space Flight Center in Greenbelt, Maryland, which is about a little about 3 hours from here where I was yesterday, and it's outside the visitor center there. And that was planted in, I believe it was around 1976, and that's growing well there, okay? That's growing well. So this is a second generation, basically spliced from this, and then sent to us here at the NASA Wallops Flight Facility Visitor Center. And this was planted on November 14th of 2023. And here I am back on November 5th, 2024, taking a measurement of this. So these are some pictures from November 5th, 2024. So I went out and took a measurement on that day when we planted it. And when I took a measurement of it, and there's a reason that date is important because we planted something else on that date. But I measured that at 118.2 centimeters. And then I went back, the following, I did a couple of measurements just to do some quick measurements right after it was planted, right after I took these measurements just to see how it was doing. Didn't grow much. It actually, the measurement got a little less because then when we hit that winter time, the really cold winter, January 16th, 2025, we had leaf off. So it actually appeared a little smaller because the leaves, the height was a little taller because when the leaves are off, you don't have that height from the leaves. And then I went out and you can see here, it's grown a bit on May 7th, 2026. So last week, I had an event at the visitor center that I was presenting at, and I measured it and it grew quite a bit. It's at 229.9 centimeters. So it's grown quite a bit since that January 16th of last year. So then at that same time on November 5th, 2024, we planted an Artemis I moon tree, not at the same, at the visitor center grounds, but not at the same location. It's on, I'm going to say it's probably about 200 to 300 feet away. I don't remember the exact measure. I'm going to say, okay, we'll say 250 feet away. But that is a loblolly pine that we got from Artemis I. So I took a tree height measurement of that on the November 5th of 2024 when we planted that one. And that was 96.4 centimeters. And then on December 5th, I did that again, 98.2. January 16th, there was no growth at all. So about a little bit over a month later, 98.2 centimeters. And then on May 7th last week, when I was there, I measured again, and we had some good growth. We had 116.1 centimeters. And I wish we had as fancy of cages there and fencing as you do up in Buffalo. I have to get on them out there at the visitor center. They just got done, power washing all the rockets that are on the visitor center grounds. So that's a first step. So maybe they're working on some signage for both moon trees there as well. But I wanted to show you that as well. And what I did hear, though, unfortunately, is that there was an Artemis I moon tree at the Goddard Space Flight Center that was planted not too far from the Apollo 14 one that unfortunately did not survive, and not sure why, if it was soil or something. So I don't know the story behind that, but the Artemis I moon tree that was planted at the Goddard Space Flight Center Visitor Center outside near the Apollo 14 moon tree did not survive. And that was something I heard, about a week and a half to 2 weeks ago. So unfortunately, not sure what happened there, but I'll try to find out. Didn't hear anything from anybody yet. But I wanted to show you this because these are the ones that we have on the grounds of the NASA Wallops Flight Facility right now. All right, with that said, I will stay quiet now after I pass it over to Peder Nelson, who's going to talk to you about NASA moon trees as heritage trees and 30 plus years of tree observations. And I will then, I have to look and see if any of those things were put in the chat from earlier. Sorry, I didn't get that for the webinar next month, but I'm going to do that now if they haven't been put in the chat yet. But I'm going to pass it over to Peder now to talk. And Peder's very engaging when he talks because he has lots of amazing information to share with you. So Peder, I'm going to pass it to you.
Thanks, Brian. I really appreciate that. And I really appreciate you students, who've joined us, who sat through what Brian was sort of talking about, because one of the things that I like to highlight for this is how you're actually setting the stage for research, right? Without those initial numbers that you guys have, there's really no way of doing any researching of how tall the tree is. Is it actually growing or is it getting shorter? So you really exemplify what we're trying to do with something as unique or interesting as that tree that went around the moon when it was, a little seedling before it even sprouted, right? Kind of that idea. So I want to share with you my moon tree that I get to work with. And the moon tree that I'm going to talk about, you can actually find more information here in the GLOBE database. And so just like you, I've actually put a lot of my observations or data into this database. And the reason is so that, one, I can share it with you guys. And then two, I now get to go look at your tree that's out there. And that comparison is a lot of fun for somebody like me who is just trying to kind of figure out the world. And we don't have a sycamore tree out here. That's actually something we don't have. So that's kind of new and interesting to be able to compare and to think about. The other thing that I want to sort of stress is the moon tree that I get to work with, it was planted in 1976. So it was one of those first generation moon trees. And somebody came along, sort of similar to your teacher there, who actually just kind of adopted it and started using it for their classes to teach students about growth. And trees are really interesting because really you only get a few observations a year. And so when we talk about growth or how healthy a tree is, we really have to have a way of capturing this over time. And that's where this database and all of your data collection is really useful. And it's most useful when it goes into a database and becomes digital. Because that digital space really allows us to start exploring this. Right. And so, this is kind of that NASA view of the world. We're looking at how sunlight reflects off of the Earth. In this case, without any clouds, because we're going to focus on what's beneath the clouds. And I'm going to go in here and show you all, we're interested in these tree heights. Right? That's a big thing that we're talking about, partly because it's something we can measure. It's an individual. As Brian has said, it tells us something about the ecosystem, right? Sometimes a taller tree versus a shorter tree. And so if I turn that on, I can actually do a little bit of a searching here. And what's nice is you can already start to see some patterns, right? And for me, what I start noticing a lot of times is where we see trees aligns with where we see green on the map. They tend to overlap each other, right? If I turn it off, you can actually see kind of that similarity that happens. You can also see sometimes where it's really dense, we're not going to get photos or data. It just takes too long, or we don't have anybody out there collecting that data. But usually it's because it's hard. I'll just say that. This is something I've seen in our data. So one of the things that I want you to pay attention to that's really important is to actually read a little bit about the data itself. In this case, one of the things that you'll learn when we talk about trees is actually that there's a height definition that sometimes comes along with these maps. And so if I actually I'm going to zoom in on an area down here that is similar to you all, planted an Artemis moon tree. And when we zoom in, with satellite maps, we don't have any idea where we are. So it's really helpful and useful to maybe switch on something that gives us some reference, right? And one of the places that had an Artemis tree, similar to you all, is here in San Antonio, Texas. And so one of the things that you might find is if you know where trees are planted, you can go look for data out there, and you might find similar data. But here I'm only seeing 3 trees or so that are showing up on our map. So I'm going to zoom in a little bit more because this is always where it gets important. Is what tree are we talking about? So I'm going to zoom in here, and we can actually see. Oh, okay. well, I can't go in too close, so I'm going to have to zoom out, right? That resolution is one of those things that I run into, Brian runs into, and is one of the challenges of doing NASA science like this. But here we can actually see it's in a main plaza. It's in a location. Oh, wow. It looks like somebody from somewhere else took it. And here I can see some of the comments that were created. So this is where it's really important to not just put information into the paper forms, but here I can actually see that somebody labeled something that they saw there, right? It was tagged as a specific tree number. And that's a great way for us to keep track of these trees as we go through. And it might also indicate that the city or the people who are in charge of these trees might already be keeping track of them. And to me, that's a really important thing because we're not the only one who cares about trees, right? So all of this information, including when it was measured and the height of it, is now stored up in that database. And we're hoping that NASA is going to do a really good job and maintain that for us. So this makes your life a lot easier. You know, you can do your measurements, put it up here, then forget about it until your next assignment, right? At least that's what I like to do. The other thing is, you know, if we're able to get a digital photo, whether it comes through your app or any other device, that's really, really useful. Like we've talked about before, right? You know, we can actually use this to identify how it's growing. It helps with your measurements, right? Because you can actually see things like the building behind it or sky color, all these things that you guys are measuring. And I bet if you were to do surface temperature measurements, here I see shaded areas, I see pavement right over here, I see some gravel. And so there's a lot of different surfaces that are going on all in this small little area. So I just kind of wanted to highlight how a ground photo like this really helps us with what you guys are all collecting out there. And it really is this confluence of information, I'll just use that word, that allows us to really understand why we're seeing what we are, right? And even how important things like shadows from buildings and trees end up really giving us this this area. So I'm going to zoom out just a little bit because if I remember right, yes, here is the location. I'm going to zoom in as a spatial tour guide. Here is the, oh, did it again. I don't like it when we have no data that shows up. Here is actually the tree that was planted, and that's about the same age as the one we just heard about in Buffalo. It's actually right outside of this planetarium, and you can actually see all of the rooftop buildings and the different colors, right? That's remote sensing right there. And so the interesting thing is, like, we can't actually zoom in and see that tree, right? So this is where our photos really come in, because we can see that somebody recorded here nice comments about when the tree was planted. So we now know how old that is, right? That's great. And I bet your tree in Buffalo that we were talking about was sort of similar. I also had to go out, similar to what Brian was talking about, and actually measure that with a ruler because it was only 139 centimeters tall. And what's important is that I did or find in here that they put in the common name. So this was one of those pine trees. So different than what you guys have. So it would be really interesting to do a comparison between that height and your height and see, are they kind of growing, you know, very similar? I just find that kind of sort of questions very interesting. But you can see that right here, we have a tree height of 2.1 meters. So again, one of the things to be watching out for is those definitions. And in the past, I'll say, anything below 5 wasn't showing up on the map. So, hey, sometimes you can be surprised with the way that data is presented. But you can see, like, that being in a planted environment like this is really, really useful when it comes to tracking this long-term research. So you can see this is just one of the many trees. So I really like that, people might actually use this and think about how it might reflect the other trees in the area. Right. So I love the full integration because one of the things that here's my moon tree at Oregon State. You can see that when I first did this data point, it was behind a chain link fence because they were actually changing the building on us. You can see that we have some big stumps and other things like that to sort of recreate that forest environment. So ours is really kind of different than everybody else's out there. And then we've actually have some of these 3D scans from above, kind of like what we're trying to do with some of the space data. But here you can actually see the shape of the building, a little geometry, and then you can actually see the tree right here in kind of that laser scanning piece. So again, they're telling us that the tree is 68 feet tall. So I think, to me, that's really interesting because now they finished the building and we can go back, and when we can actually see during the winter, we can actually see how tall that tree is. We can actually see the plaque that they put up there and some various things like that. And I wanted to end with this little piece of things of this is why those up photos are really valuable, right? Here you can actually see the structure of that tree, the tree canopy, and that's really what we're trying to sort of track over time. So, with that, I hope that, we are able to keep putting our data together because it becomes really, really fascinating as you guys start contributing and we are able to start working in this digital space like this. So, like I said, I hope that you have seen how we can actually work together through this digital sharing of information. And a little bit of some aspirations for maybe what you'll do this summer, but definitely make sure that you not only make measurements, but you share them out in this way so that we can have the data over the long term and you don't have to actually think about this anymore once you leave this class or once you've made your measurements, right? That's kind of the job for people like Brian or Peter or some of the other people on our call. Right. So I'm going to stop right there and ask, does anybody have any questions about the data piece, how you're archiving your data to finish the science process? All right. Brian?
All right. Thank you, Peter. Does anybody have any questions about anything during the webinar today? Anything for Peter, for me, for Peter Falcon? Anybody want to? Oh, Lisa said, my students are amazed at the height of the pine tree.
Yeah, and again, it started off small, just like yours.
Yeah, they were, when they saw the picture of it against your building, they were like, "Wait a minute, is ours going to be that big?" How old was he? They didn't click that you said that you had one of the original ones from 50 years ago. Yeah,
yeah,
they were all kind of they kind of stopped in their tracks. They're like, "Oh my gosh!" But yeah, that's awesome.
Yeah, and I'm glad that you guys noted that because those trees actually can grow up to 400 feet tall. Yeah, so if you think about if it just grows 1 foot a year, that's 400 years of a research experiment before it might even get close to its maximum height, which, to me, that's the research project that we're doing. It's, it's really, with some things, it's really short. They might not live, like Brian was saying, past, you know, the seedling stage. Others, we're hoping that they'll go that whole life. And then importantly, out here in Oregon, where I'm at, if that tree falls down, it's almost another 400 to 1,000 years for it to decay and go through its process. So if you really think about the whole carbon cycle, this could be a really long-term research project, and I'm only doing my little part right here. So you guys keep it up, and I look forward to seeing those growth rates going on, because they are really very different across the country right now.
Absolutely. Yeah. My students also said that on the map that you showed, our moon tree is not mapped on that map.
Okay. I'm going to have to zoom into the Buffalo area, because that, I think, is one of those. And this to me is the database piece. We've got a lot of databases all over.
Yeah. I think we have 6 in 6 days or 5. I put 5 heights in with photos. So there is some record of it being there. And when I log into my Observer app and I hit trees, it will show me as one of my locations, moon tree, like it populates as a location on my app. So, I mean, we're definitely in the database. And I was just looking, because I didn't even put those stats on my slides, and I probably should have. But it looks like my tree has grown 2 meters. No, it wouldn't have been. About
That's excellent.
A quarter of a meter. So maybe a foot, and maybe a foot that's grown. Yeah.
Yeah, and like I said, ours at Oregon State University ended up being something that was tended and watered and cared for, and so, you know, to me that's a whole different sort of experiment than putting one out in the wild and letting it go and like seeing what happens, you know, when you don't sprinkle it, when you don't prune it, when you don't actually do some of these things, and we've seen that in Oregon. Actually, we've got quite a few of these over time. So it turns into a nice piece of history that you get to pass on.
Correct. Yeah. Yeah. We do have the groundskeeper keeping track of it during the summer on those dry months. Yeah. It's really the only time they throw some water on it, you know. Other than that, we kind of let it go, you know, let it do its thing. The more I think you touch it, the more sometimes you don't do good for it either.
You mess with the experiment, right?
Exactly.
Yeah, exactly. So
I also noticed when I was just looking, I was looking at my data when I measured it in the spring or summer, like last couple of days of school, and then I measured it again when the leaves were gone. It had shrunk as well. Yes.
Remember, just an estimate, right? Unless you're climbing up that tree.
I mean, the leaves, I think our biggest leaf we had last year was like, because they're sycamore leaves, so they're pretty big at the end. So when they drop, I guess you would lose almost 6 inches on the tree.
Yeah, definitely. And that this really gets into some of the conversations that scientists had last week at a conference that we were at, where we were really talking about this. You know, how precise do we have to be in our measurements? Does it matter? Again, kind of this leaf on, leaf off piece. And I'll just give you guys all a career advice. Yes, it matters, but in a certain way, it doesn't really matter. Just make a choice. Don't forget about why you're making that measurement, right? So again, you know, I think it's a lot of fun to get to understand how we're doing all of this, but sometimes a decimal point doesn't really matter when it comes to making a choice. And remember, that's really why we're doing a lot of this, is to help us make choices. I want to, like, everybody, I hope you come back and hear more early career scientists and how they're contributing to our database and what we're working on, and how you all can, everybody here can actually be part of this peer review process. So, you know, this has been a lot of fun thinking about these long projects that is really the foundational piece of what we're doing with Globe. And I just want to thank you guys for everybody here making their contributions at their moment in time. And then, like I said, you can just run off now and forget about it until you have to make your next measurement. Brian?
Yeah, I like that. That's a great ending, Peter. Yeah. All right. Thank you, everyone, for being here. Thanks again to Lisa and the students for presenting today. And as a reminder, tomorrow is the Globe Observer Connect event. I put the link in the chat. You might have to scroll up a little bit in the meeting chat. check that out and register for that. I hope to see you there tomorrow at it would be 12 Eastern for that as well. I think it was 1600 UTC. But yeah, check that out. You can register for that as well. So for the entire Trees Around the Globe Student Research Campaign team of Peder Falcon, Peder Nelson, and myself, thank you all, and hope to see you either at the Globe Observer Connect and definitely at next month's webinar. So thanks so much, everyone, and see you soon.